All right. So today, what we're talking about is something called compound interest. Compound interest. Compound interest is how banks calculate interest. How wherever interest is calculated, mostly in banks. Okay. So my question is why? My first question is why do we use banks to store our money? Right. The money we get from working, the money we earn, right? We can just put in our house, in our safe, buy a nice big safe, put the money in there, and whenever I need it, come back. Why do most people choose banks to store money? What's one of the reasons? There's several reasons, but what's one of the reasons? Yeah, you get money actually. Yeah, what is that called? Interest, right? When you give your money to the bank says not only will we keep your money and not lose your money, but we will give you money back just for doing that. It's called interest, right? It's called interest. Good. So here's my question. What happens? I have two questions. What happens if the bank gets robbed? What happens if a bank gets robbed and then you take all the money in the bank? Like I go to a bank, I put my money in the bank, I walk out, later it gets robbed. They still your money is safe. Yeah, does anyone know why your money is safe in a bank that just got robbed?
I think they have a law that says you can get up to like 10,000 in the bank to like keep that much amount safe.
Exactly. Yeah, you guys are probably talking about this in U.S. history. It's something called the FDIC. Anytime you go to a bank or you use a bank, look for that. Because if you can't find that anywhere, don't go in the bank. Because the FDIC is the Federal Deposit Insurance Commission. It was created by FDR after Black Friday or Black Tuesday. Was it Black Tuesday? Black Tuesday. What was Black Tuesday? Yeah, 1929, the market collapsed. Market collapsed, everything was worthless. So the market is where companies are worth, right? If I want to buy shares in a company, I go to the market, I pay whatever the cost is, right? Give me 1 second. So the FDIC was a law started by Franklin Delano Roosevelt after the Great Collapse. What happened in Black Tuesday was that everyone lost their money. Everyone lost their money. Banks lost their money. All the money is gone. So what happened was people went try to go get their money, and the banks were like, "I don't have your money." There was no way for the people to get their money back. Literally, everyone lost their money. It was the start of the Great Depression, right? You guys have seen pictures of the Great Depression. So yeah, that was the start. After that, they said, no, if banks don't have your money, we will step in as a federal government, right? There's right now in the news, there's like 3 banks that just went out of business. 3 banks just went out of business. And the next day there was a line. Today in 2023, there was a line outside the bank trying to get their money. And the bank's like, we don't have your money. We went out of business. So the government stepped in and said, everyone who had your money in the bank, don't worry. You won't, you'll keep your money. So that brings my next question. How do banks make money? How do banks make money? Like they have to have a way to pay me, right? Because I'm putting my money in the bank and they give me interest. How do they have how do they pay me? What do they do? Like what is the bank? What is the job of the bank? How do they make money?
I feel like federal income is their government thing.
Say it again.
Like off federal income, or like they're part of the government. They get paid by the government.
So they're not a part of the government. Yeah, the government and the banks are separate as much as possible, but you're close. You're getting there. What's a way they make money?
Don't they like recycle the money, like to help people have credit cards, and then they like charge them more money if they don't pay off their things?
Exactly. They recycle the money. When I go give them, let's say I deposit $100 into the bank. They don't keep that $100 in a safe spot. What they do is they go out, and at the same time when I'm depositing the money, someone is asking, like you go into a bank, there's tellers, right? And then the other side is offices, right? Is desks. Like, what do they do? This is what they do. They give loans out, right? One way they give loans out, they give different kinds of loans out. Home loans, car loans. If you want to like redo things to your house, credit cards, different things like that. That's one of the ways they do it, right? Credit cards. This is how credit cards work. I go to Best Buy and I buy a brand new TV for $7,500 or $750. I buy a new TV for $750, right? I don't have that money in my pocket or I don't want to use my money. So I use what's called a credit card, right? So I give them a credit card, they scan it, they let me go. Credit card company says, we'll front you that money, whoever the credit card company is, if it's a bank or whoever. And then you have to pay what's called fees. Now, credit cards are one of the biggest ways people get in trouble because credit cards have high interest. Credit cards have something like 20% interest, which doesn't seem like a lot, but it is a lot, right? So if I pay off, so let's say every month you have to pay. Let's say I go to the bank, let's say I go to Best Buy in January, buy a TV, use my credit card, I pay it off. I pay off the whole thing. Let's say I pay off the whole thing in February, 1 month. They will have charged me 20% interest. 20% on $750 times 20 is $150. So that means when I paid it off, I didn't pay off $750. I paid $150 plus $150. So I paid $900 for that TV, right? If you don't pay it off, every month that 20% gets tacked on. Every month that 20% gets tacked on. So let's say you pay it off in 2 months. So you get $750 times 20%. So that means my bill is no longer that. It is that, right? After 1 month, it becomes that. Well, now my bill says 900. And then so they do the next month. That's 20%. So now instead of 900, it's 180 plus that. So after 2 months, the $750 TV that I bought is now costing me $1,880. Right? That's crazy, right? That's how much in 2 months. In 2 months, right? That's how credit cards work. So it's just that's how people get credit card debt, which is not a good thing, right? So you always want to be careful with credit cards. Banks know that. So they give people credit cards. They'll give when you get older, you will literally get mail of all of these credit cards. And they'll mail you a credit card and say, you've already qualified for this because they know that, right? They know that. So you just got to be careful with that kind of thing. Home loans, right? If I go buy a home for $300,000, I don't have $300,000 cash. I don't. So what you do is you get a loan. Their home loans aren't, their percentage is not as high. Like a good home loan right now, you can get for about 6%, like about 6%. But it's 6% of $300,000. That's a lot of money, right? So all of that interest, that's how the bank makes money. How does a bank go out of business? How does a bank go out of business? What do they? They give their money, they give loans out to people who can't pay, right? 20% interest is great, but if you give a credit card to someone who can't pay, let's say you take the TV away. Okay, I'll take the TV away. That TV I can't sell for $750. So I lose money, right? Things like that, right? So if a bank makes a bad loan, they can't get their money back. So that's why banks go out of business, right? That's what happened on Black Tuesday. Black Tuesday, banks were doing things they shouldn't have been doing. So it all hit at once. At one day, Black Tuesday, October 29th, 1929, it all came to a head and nobody had money because it all was worthless. Okay? So that's how banks make money. That's how banks make money, by interest. Okay? So how do they calculate the interest? How do they figure out how much interest to give you? Well, there's 2 ways. There's 2 formulas. They both look very, very similar. There's A's, P's, R's, and T's. One of them has an E and one of them has an N. Okay? We're going to talk about that. So the first one we use almost all of the time. The second one we only used if it's compounded, what we call continuously. Continuously. If they use that word continuously, we use the second formula. Okay, so let's write down. I kind of have it on the board, but let's write down what each of these letters mean. Capital A. Capital A is total amount accrued. Total amount accrued. Accrued. Accrued means earned, gained. How much money do I have in my account right now? That's accrued. Accumulated, gathered. Okay? That's what A is. Capital P. Capital P is principal. Not like the principal of a school, but like principal money. What is principal money? If I'm a business, I need principal. What is that? Especially if I'm a new business, right? If I'm a new business, if I open a restaurant, I need principal to start the job, right? Principal is starting money, starting dollars. I can't just say, I want to open a restaurant and have no money. You have to find a space, you have to rent the place, you have to buy the equipment, you have to hire people even before you start to open, you have to buy all of the overhead, what we call it, right? So that's how much money you start with. Okay? R is the rate. R is the rate. What rate are they giving me? Right? Rate. They usually give you as a percent, but remember, we have to change that to a decimal. So don't forget to change it to a decimal. If you want to change a percent to a decimal, divide that percent by 100. Or just move the decimal over. N. So the top one has an N, the bottom one doesn't have an N. What is N? N is the number of times compounded per year. What is compounded? Interest. How many times are they putting money into my account? How many times are they putting money into my account? My bank puts money in once a month. Once a month, I get a statement saying this is how much money, this is how much interest they put into my account. Banks do it. Some banks do it every day. Some banks do it every month. Some banks do it every year, once a year. It just depends on the bank.
What if you just pay it back?
Pay what back?
Like if you get a credit card bill at the end of the month, how don't you just pay it back at the end of the month?
It depends. It depends. Yeah, it depends. Will they charge you that 20%? Sometimes you'll see like 0% APR. That means if you pay it back within a certain time, we won't charge you anything. So when you're going, depends on each credit card. Depends on when you use. Usually the credit card within a month, if you pay it back, you're good. You don't have to pay any charges. Usually.
So some credit cards have it where you automatically have interest.
Yeah, that's where you got to be careful with credit cards. You want to choose credit cards that are friendly to you. And then there's some credit cards that charge you every year to use it. You could not pay one thing and then they'll be like, to use our credit card, you have to pay $500 a year. You're like, I didn't even use it. Why do I have to pay? So those things like that. So you just got to be careful with credit cards. If there's one thing I could caution students about in the future, it's credit cards. I'm not saying don't get one. That's not realistic, but just be careful. Just be careful with them because, yeah, that's how people get in trouble. Yeah. Do your research when you're buying when you're using a credit card, do your research to find the best deal. T is time. Years, usually. It's in years. Time in years. Okay. E is not a variable. So E is an amount. Actually, I used equals. I'm going to use the wavies. The wavies means close to, because there's not really a number for E. E is 2.7182, and it continues. E is a number that they use in the financial industry to find interest. It's a value. Where does it come from? I'm not going to really get into that. Where does it come from? I could tell you where it comes from, but it's just don't need to worry about that right now. It's a number. The main thing you have to worry about is its value and that it's not a variable. From now on until in every math class you take from now on, E is no longer a variable. E is a number. It's kind of like pi, right? Pi is 3.14, blah, 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 blah. It's exactly like that, right? E is not a variable. So from here on out, anytime you see E, it's that value. Your calculator knows E, though. Your calculator knows E. If you go to the function key up at the top, it's right there. Right there, E. So if you plug in E to the first power, which is just E, it gives you that number there. Okay. All right, so that's what everything stands for. So which one will we use? It just depends on the question. If it says continuously, we use the second one. If it says compounded yearly, monthly, daily, quarterly, we use the top one. All right, so let's look at number one. Tanya invested $390 in an account, paying an interest rate of 2.7% compounded daily. Assuming no deposits or withdrawals are made, assuming within the time she has the money in the bank, she doesn't touch the money. $390 just stays. How much money is she going to have to the nearest cent after 18 years? So she puts in $390, doesn't touch it for 18 years, comes back in 18 years. How much money will be in that account? That's what we're trying to figure out. Okay? Okay, so first thing we need to do is underline, circle, highlight things that are important, right? Not every single word in there is important, right? Understanding what to look for. First thing, she invested $390. That's important. She's getting an interest rate of 2.7%. That's important. Compounded daily. So every day they're putting money into her account. Every day. Could be pennies, could be dollars, but they're putting money into her account. And then how much to the nearest cent after 18 years? Okay, so the first thing is, are we going to use the first equation or the second equation? The top one or the bottom one? Does it say compounded continuously in the question? Daily, right? Anything other than continuously, we're going to use this guy here. Only time we use the bottom is when it says continuously. Because continuously, define continuously. How many times is continuously? Is it once? Is it twice? Is it 100 times? Is it 1,000,000 times? I don't know, right? If it says daily, how many times is daily in 1 year? If I do something daily and I do it for 1 year, how many times do I do it? 365. I can put a number on that. Continuously, I can't. Continuously could mean every minute, every second, every day, every year, so that's why we use that one. Okay, so here we go. A is the amount accrued. That's what they want to know, right? How much money? They want to know how much money, so that's A. Principal, P. What did she start with? $390, right? $390. You have to start with something. You can't go to a bank and say, I want to open an account and not have any money. You have to have some money to start with. Okay? Parentheses. 1 plus R. R goes on top. R is the rate. The rate is 2.7, right? We don't put 2.7. We don't put percents. We put rates, R. So 2.7%, I need to divide it by 100 or move the decimal. So when you do that, you're going to get 0.27. That's the number I need to put on top. N, number of times. So if I do it daily, we said 365 in 1 year, right? So 365 goes there. And then I put that number again on top as a power, times T, the amount of years she's going to keep the money in her account, 18 years. Right? This is where we're going to go to our calculator. We're going to do what we've been doing for the last couple days. Go right to our calculator. Okay, so let's go put the calculations in. 390 parentheses 1 plus 0.027 divided by 365. Here's where we have to do real quick. The calculator doesn't like us when we try to do multiplication or addition or anything as a power, right? Watch. 365 times, and then it goes down to the bottom, right? Times 18. It won't let me do it that way. So when you're using this calculator, you have to do the power first. So we have to calculate the power first. So 365 times 18. 365 times 18. Do that first, and then move the power to the top. 6570. Okay? So do the power first, and then plug it in, so that the calculator will give you an answer instead of giving you the wrong answer. Okay? We need to round to the nearest cent. Round to the nearest cent. Well, what number is in the cent spot? 5, right? 0. So the decimals after, right? The place values after the decimal. 0 is in the tenths. 5 is in the hundredths or the cent. So we look behind 5 and there's a 0. So we keep it at 5. So $634.05. Okay, a lot of people look at that money and say, oh, that's not that much money. Well, she didn't do anything. It's not like she put more money into the account. She literally left it, and for no reason at all, it went up almost $300, $250, right? So that's how interest works, right? The more money you put in, the more your interest is going to be. $390 at 2.7 is not a lot. But the next one, $60,000 at 4.7, it's going to be a little bit more. Okay? All right, so I want you to do this one now. I want you to do this one right now, and then we'll go over it in a few minutes. Which formula are we going to use before I let you work? Which formula, the top one or the bottom one? Top one, because we know how many times it's compounded, quarterly. So compounded quarterly means they put money into his account every 4 months or every 3 months, 4 times a year. So that's why it's 4. 4.7. That's what happens. If you put more money into a bank, they're more likely to give you a higher return. They want you to put more money into the bank so that they can make more money by lending that money out. Okay? So we get $100,316 and some change. So what number do we need to write? Nearest $100. 100. Well, which number is in the 100 spot? 3, right? 3 is in the 100 spot. So we look behind 3. It's a 1. A 1 says we stay where we're at. So that becomes a 3. What happens to everything behind the 3? Becomes a 0. Yep. So it becomes 100,300. Everything behind the 3 just turns into a 0. So after 11 years, less time, over $40,000, almost doubled. More money, higher interest rate means more return. Okay? All right, let's look at number 3. Look at number 3. So number 3 looks like a similar problem. So read number 3 and tell me what's the difference between 1 and 2 and this one here. Now we got continuously, right? Now we got that word continuously, right? The rate is 1.8%. How much money after 16 years? Continuously. I can't put a number on continuously. If I do something continuously for 1 year, how many times do I do it? I don't know. A lot. So that's why we use the second formula called the PERT formula. Still have a P, still have an R, still have a T, but now we have an E as well. Okay, so let's plug in these values here. A equals P times E to the R times T power. We're trying to find out how much money Hannah's going to have after 6 years. Principal is what she starts with, $820. Remember, E is not a variable. We don't plug in anything for E. We just write E because E is a number now. Okay, our calculator knows E, so don't worry about what number it is. R is the decimal, 0.1018 for 1.8%. T, 16 years, 16 years. Right? Before we put our number into, before we do anything, before we try to get an answer, multiply that first in your calculator. Multiply that first before you put it in. Okay, so let's go. 0.018 times 16, was it? Yep. That's going to be my power. So now I'm going to put in how much money? $820 times E. E is going to be under the function. E is under the function. And then what power do I want? I want the power from my previous answer. So I'm going to go back to main, and I'm going to hit that answer button right below 3. Right below 3 is the answer button. That's your old answer. And that's the number. $100,093 and change. $1,093 or 100. Did I say 100? $1,093 and change. So we have to round to the nearest $100 again. The nearest $100 again. What number is in the $100 spot? 0. So the guy behind it is a 9. We're going to round up. So that's going to be 1, 1. The rest become zeros. The rest become zeros. 1, 1, 0, 0, decimal 0, 0, 0, 0. We don't have to write all those decimals if it's 0. $1,100, $1,100. Okay. All right. Okay, so the last two, the difference between the last two is now we've been trying to solve for A this whole time, right? Now they're going to give you A, and they're going to be missing something else. So we have to figure out the missing part, okay? So Grace is going to invest in an account that pays 3.8% compounded continuously. How much would Grace need to invest? How much does she need to start with if she wants to have $46,000 in 13 years? $46,000. That's how much she wants to have. Okay. Continuously, right? Compounded continuously. So we're going to use the PERT formula. Okay. We have to figure out what we know and what we don't know. Rate. I know the rate, right? $46,000. What is $46,000? Is it how much we start with or how much we end with? End, right? $46,000 is how much we end with. So that's going to be over here. It's not going to be P anymore. In fact, the question is asking how much do we need to start with? So we don't know P. So I'm just going to leave P as just P. E is not a variable, so we don't plug anything in for E. I know rate though, right? Rate 0.038 and then times 13 years. So now my question is, how do I solve for P? I want to get P by itself, right? I want to get this guy by itself. Nothing other than P on that side of the equation. So what am I going to do? I'll give you a hint. You either there you don't divide by P, divide by everything other than P. We want to keep P there, right? So we're going to keep P there. So I'm going to divide by everything that's not P. Why divide? Because isn't P being multiplied? So the opposite would be division. So if I divide by this, all that's going to be left is 1P. Because that becomes a 1. All right. So now what I'm going to do is I'm going to put this into my calculator. And the nice thing about Desmos or Delta Math is you can actually put this exact thing in there. The only thing it won't allow you to do is we have to calculate this percent or this guy first, right? We have to multiply this guy first. Once I multiply that guy, then I can put it in, okay? So this is what I'm going to do. 46,000 46,000. And then I got E, right? E. And then I'm going to hit another row. I'm not ready to put E in yet. E is 0.038 times 13. 0.038 times 13. 13. There we go. That's the decimal I want up there. 0.494. 0.494. Okay. $28,068 and change. They want it to go to the nearest cent. The nearest cent, again, 1 is in the cent spot, right? 1 is in the cent spot. 6 behind it says go up. So it's going to be $28,068.32. That's how much Grace would need to start with. Grace needs to start with that in order to make $46,000 within 13 years. If you're trying to save for something, it makes sense without having to borrow. Okay. All right, last one. They're missing something. This one's missing something too. They're always missing something. What are they missing? Oscar is going to invest $79,000 and leave it into an account for 9 years. So we know he starts with $79,000 and we know he's going to keep it in for 9 years. Assuming the interest is compounded monthly, how many times in 1 year is monthly? 12. So we're using the top formula. not the one we just used. What interest rate? That's what we need to find out. What rate would I need or would he need to end up with $96,000 at the end of those 9 years? Okay, so let's write down our formula. A equals P 1 plus R over N, N times T. We're going to fill in what we know, and what we don't know, we're going to solve for. A is the amount at the end, $96,000. P is how much to start with. He said he's going to start with $97,000. 1 plus R. That's what I'm trying to find, right? Interest rate is what I'm trying to find. So I'm not going to have any, I'm just going to have an R there. N is the number of times compounded in 1 year. So if it's monthly, what is it going to be? 12. N times P, 12, or N times T, sorry, 12 times 9. I have to solve this guy for R. Okay, so let me rewrite this. So this is $96,000, $79,000. 1 plus R divided by 12, and then the power is going to be 108 because 12 times 9 is 108. So this is the guy I need to get by itself on one side. So I slowly got to get rid of all of these things. I got to get rid of the 79,000. I got to get rid of the 1, the 12, the 108, but I have to do it correctly. This kind of looks like a problem we saw the last 2 days. What did we do then? There you go. Yeah, we can't distribute because of the power, so let's divide. Let's divide by what we can. $79,000. That's what we did the last 2 days. That worked. That becomes a 1. Okay, so let's go to the calculator. It's going to be a decimal. $1.215189. So we're going to go 3 spaces past the decimal. 1.215. We'll say 1.215. Good. And then how do I get rid of the power? What did I do to get rid of the power? Take the root, right? Take the root, 108 root, right? 108 root gets rid of 108 power. And you're going to get something 1.001. It's going to be 1, very close to 1 when you do that in Desmos. Right, let's see, let me double check. Previous answer, yeah, 1.001. Or we should go 2, right? 1.002. Okay. Need to get R. Almost get R by itself. Got all the hard stuff. How do I get rid of the rest? Subtract 1 from both sides. When I subtract 1 whole, I'm just left with the change. Last step. Last step. How do I get R by itself? Multiply. Yeah, it's being divided by 12, right? The opposite of divided by 12 is multiply by 12. Oops, wrong one. Nope. Let's see. So take that answer that I got, minus 1. Oops. Take that answer that I got, multiply it times 12. All right? And what rate do you get? See, did I do that right? Feeling like I did something wrong somewhere. No. 0.0217. 0.0217. 02. Let's see. Okay, so we haven't changed it to a percent, right? So it's still a decimal. So now let's change it to a percent, right? How do we change it to a percent? Multiply right there. So it's going to be 2.17%. And then it said 1/10 of a percent. 1/10 is this guy right here. So that means it's going to be 2.2%. 2.2%. Yeah, so decimal, change it, and then round it. We have to round it after it becomes a percent. Okay. All right.